Next we see what are non-graphical bivariate analysis. Bivariate analysis by definition means analysis of correlation between two variables. Non-graphical, as we know, is the numerical summary. So .cor method. .cor method provides a summary of correlation coefficients between given pair of variables. Below instruction will generate a summary of the summary in reference to MPG with all other variables. For example, weight, displacement, etc. So let's run the below entry and analyze the output. So let's do that now. df underscore cars dot cor is correlation. Next, go one position forward, open bracket, single quotes, MPG, because we are doing in reference to MPG, dot sort underscore values, then open close parenthesis, shift enter. Right. So what does it say? The above response gives a quick numerical summary of how mileage is correlated with each one of the listed numeric variables. As expected, weight, displacement, cylinders, horsepower all show a strong negative relationship. That is, as these increase, mileage drops. This is understandable as they all are logically connected. Car weight is primarily driving the horsepower, which in turn drives the displacement and the number of cylinders. Acceleration, on the other hand, behaves differently depending on the range of values. On the lower side, it improves mileage with higher acceleration. Beyond some optimal mileage, we know all this, right? So raise the higher acceleration to a very high value, the mileage goes down. So higher acceleration reduces the mileage. Year shows positive correlation because with increasing year, the technology improved and so did the fuel efficiency and mileage. So now the next one is graphical bivariate analysis. Plotting of two variables against one another reflects the correlation between them. Conceptually, bivariate correlations extends into multidimensional patterns. Since MPG is our target variable, so we can check the correlation between MPG versus rest of the fields like weight, horsepower, displacement, etc. We can check a few bivariate scatter plots against mileage to know what factors influence mileage. As expected, weight, displacement, cylinders, horsepower all show a strong negative relationship. As these increase, mileage drops. So I'm going to give you one type variation of horsepower with MPG. Now remaining you can replicate. Now this is a standard syntax, so let's not spend a lot of time in typing it. So I'm just going to copy and run it here. So we are here. So here, what are these instructions do? So we are df cars dot plot. Along the x-axis we put the horsepower. Along y-axis MPG, style equal to output. Plot title we are giving an x label, y label, and plot dot show. Shift enter. So we have generated a scatter plot. So this is how we show the bivariate relationship, correlation between two variables. Now here is something very important instruction which will be all in one solution. So let's see scatter matrix plot. Now here is an all-in-one quick visualization tool called scatter matrix. It includes each bivariate plot and each histogram we studied above all together at one place. Having seen each plot individually, in practice we can simply run scatter matrix plot and get a full view of the data. So let's run below instructions to generate a scatter matrix of our df cars data frame. So let's do that part. Scatter matrix plot MPG. Here is one field we need to define. MPG equal to df underscore cars MPG, because we'll be referring to this variable as such. Now note that here we are importing another library, pandas.plotting for scatter matrix. So let's do that part. From pandas.plotting, pandas.plotting, import scatter matrix, scatter underscore matrix. Next, scatter matrix, scatter underscore matrix, round bracket, df underscore cars, comma, fig size. This is the figure size. However big or large, small we want, we can. Here is an option to specify that. How much dimension on x-axis, how much on y-axis. So I will choose 16,10. I want a smaller one. We kind of have an idea what the content. So let's create a smaller one. You can increase this or you can play with the dimension to get a feel of it. So alpha equal to 0.5. Diagonal. This diagonal says either we can give an option as a curve or it can give it as a histogram. I'm going to give it as a histogram. So we can give it as a KDE. That's another option. If you press Shift Tab, it will show you various options and it will give all nice documentation of the whole information from Pandas application. It's online available. So you can just press Shift Tab and do that. So let's generate this. Are we correct? Scatter matrix, DF cars, fixed size, 1610. Shift, enter. Now it's running. It is going to generate a graph like this. So this big graph is here. So let's see what this graph tells us. As we see, scatter matrix is giving us all possible combination of univariate histograms and bivariate correlation plots that we have been looking at so far, all at one place. So we have MPG, we have cylinders, we have displacement, we have horsepower, we have weight, acceleration, year, everything. So you can check and you can get familiar with this. This is very important and useful tool and you can make use of this. So as we see, we got all this information and now we are ready to set up our machine learning model. At this point, let's review our work so far. Like we saw, we began with understanding the business requirement. We interpreted the requirement in customer's perspective. Then we gathered the domain knowledge so that we understand our system better. Our scope of work was limited to whatever data contains. So we kept mapping requirements to the data available. Then we identified MPG as our target variable and the remaining features as potential predictors. We decided to drop some of the features like model name, number of cylinders, etc. Then we moved on to data pre-processing, cleaning and getting the format right. Finally, we use visualization techniques to understand each feature individually as well as the correlations between various parts. Now for a quick recap, as we know our regression equation, now this part I'm going to repeat one more time so that we to emphasize on you what exactly is the business we have on hand here. So for quick recap, please pay attention to this. As we know our regression equation is defined as y equal to a0 plus a1x1 plus a2x2 plus a3x3 etc. And like this so many variables n xn where y is our target variable and the label mileage which is our label mileage we know. X1, X2 etc. are predictors like weight, displacement, horsepower, year, all that we have seen. In machine learning, we are going to use gradient descent optimizer to find the optimum values of coefficients a0, a1, a2 etc. of variables x1, x2, x3. This gives us minimum error. The combination that gives us minimum error will be found out by gradient descent optimizer. It will do trial and run with a number of samples and arrive at the best combination of values. So minimum error between predicted value and actual value. So let's see how we do this.